All right, everybody. I think this is where I finished off the last lecture. Let's go ahead and make it a little bit bigger so everybody can see. We were talking about the broad idea of risk control. So yeah, you can insure against risks, but maybe there's something you can do to prevent the likelihood of risks, or maybe prevent the severity of risks. And that's risk control. That's what we're talking about. Again, avoidance is a real simple method of risk control, but most of the time that isn't going to be your best option because you're not going to be able to get around to facing these risks somehow. If you want to be in business, that means you accept the risk of fire. And so the question is, all right, we're going to insure against it. How do we prevent against it? So we're specifically going to start to talk about fire. And we spend a fair amount of time on that, but we'll get to other physical risks as well. So as far as fire goes, there's three things that we need to be thinking about. There's heat, there's oxygen, and there's fuel. You need those three things to have a fire. So when you think about heat, where does heat come from? Well, electrical systems can generate heat. Chemical systems can generate heat. Mechanical systems with friction can generate heat. So most of the time here, when you're thinking about these things, it's manufacturing that really gets the attention. But some of these are present in retailing too. The electrical part of it, any building is going to have an electrical issue. Mechanical, that's pretty well limited to manufacturing types of concerns. Not always, but that's primarily where you're going to find that. And then chemical sources of heat, that sounds like a process too. The standard building that's just a retail space, chemical sources of heat don't really seem to immediately be a main source of fire. And then, yeah, nuclear sources of heat too, in very specialized processes. So really we have two sources. They're either planned or unplanned. And unplanned is where we're going to have the most difficulty in trying to apply loss control. The planned places where heat exists, we can start to look at a process and say, oh, that process generates heat. What can we do to minimize the possibility of that heat turning into a fire? Where it's unplanned, it's a little bit harder. It takes a little bit more imagination. But that's where risk managers shine, is in the element of imagination. As far as oxygen, just regular air is 21% oxygen. And so just the fact that a fire is burning by itself, most of the time it's creating a draft, and that's helping to resupply oxygen to the fire. If you can somehow choke off that oxygen flow, that will put the fire out. That's why they tell you, for certain types of fires, smothering it is the best thing you can do. And we'll talk more about ways that can happen. So yeah, if you happen to have a blanket and you've got a grease fire, remember, water will spread a grease fire. That's something we're going to come up against again too. So smothering that is your best choice. And if you had to have a blanket, that'd be one way to do it. We've got chemical systems that'll smother fire too. The more concentrated oxygen that you have in an area, that's going to create a fire risk. And then we have some chemical combinations can create fire without oxygen. That's rare, but it's possible. Oxygen is an important element of most fires, and that's why we're thinking, well, what can we do to remove oxygen from the area? And yeah, that's going to take a system. It's going to take a process. It's hard to do that just naturally. And some of the fire suppression systems that we're going to talk about, their main strategy is to eliminate oxygen. So hoods that we have over restaurant cooking surfaces, most of the time, the fire suppression that we're using there is going to be something that's intended to smother the fire by depriving it of oxygen. And we'll talk more about those systems, whether they're dry pipe or wet pipe, and what that means as we move along. Then we have fuel. Something has to burn. It can't just spontaneously combust with nothing to keep it going. If you run out of fuel, the fire stops, right? I mean, you have a campfire. When all the wood is gone, eventually your fire is done, if it's contained, right? How hot does something need to be to burn? Well, paper, a common source of fuel, needs to be 450 degrees Fahrenheit, 451, right? Fahrenheit 451, famous novel. That was how it got its title, was the idea that paper burns at that temperature. So every substance that we have, we know what it takes to burn that, and everything can burn. I mean, steel will burn if you get it hot enough. I can't remember exactly where you need to be. It's 1700 degrees Fahrenheit, something like that. It's really, 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 really hot, but even steel can burn, is my point. So it's just a matter of how hot you get it. So anything can be fuel. And when you start to think of the objects that you have in place as fuel for a fire, that's how you start to get to the strategies of risk control of how do you reduce the possibility of fire. Sometimes we talk about a flash point. That's when you're using liquids. Liquids, then when they're heated up, they release vapor. And then that vapor mixed with air could form something that can ignite. And the most common one to be thinking about here is gasoline. And there it's a relatively low temperature. Gasoline can burn at a very low temperature or can vaporize to mix with air to give you the mixture that you need to be flammable at a very low temperature. Diesel is totally different. So fuel oil furnaces, for example, are using basically diesel fuel. That's what's happening. And the nice thing is it's so much safer because it actually has to be fairly hot before it can ignite by itself. Gasoline doesn't have to be hot at all. In fact, I mean, how often does it happen that we get 45 degrees below Fahrenheit where gasoline can't mix with air to form a vapor and mix with air to ignite? How often is that going to happen? Most of the time, 365 days a year, you're above negative 45 degrees Fahrenheit, right? And maybe some parts of Alaska might have a few days below that, but otherwise in the rest of the U.S., that's extremely rare. So that's why gasoline is a fairly dangerous liquid, has a fairly high fire risk, and any storage of gasoline that you do, you need to be thinking about how do you protect that against the possibility of a flashpoint where you could ignite a fire. That's a fuel issue that we talk about. When we talk about the fire load, we're talking about how much combustible weight per square foot do we have. The more that you have, the more dangerous it is. And it's interesting because most of the really high fire loads we don't think of as dangerous, right? Think about bulk storage, a storage facility, right? Okay, so a rental place where they're renting out their units, most of the time those units are packed pretty full. And you don't really think of that as a fire hazard, but that's the whole point. They're packed really full, and most of those things can burn. And once that gets started, putting it out is going to be difficult because you have such a high fire load. Another place, storing paper, right? You don't think of that as dangerous, but from a fire perspective, it's extremely dangerous. Once a fire gets going, the rest of that is going to go too. How do you stop it? And the heaviest fire loads are always going to be from the most flammable materials. So as you look around the property that you have as a business, if you think of everything as potential fuel, you know, sure, you're looking at certain things and you're saying, well, that doesn't seem like much of a fire load. Okay, I've got a big machine. You know, it's made out of steel. Yeah, okay, it can burn, but it's going to have to get really, really hot. That's probably not going to be where the fire is going to start unless that is a process that's generating heat. Then that's a possibility, but it'll probably be something else that catches on fire, and then it'll spread from there. So it's the most flammable things that create the highest fire load, and that's what you're thinking about when you're thinking about where things are placed in your building and where they're located and their proximity to other things. The building itself, we've got 5 different classifications that ISO has come up with, the Insurance Services Office has come up with to classify what buildings are. So a frame building is the most flammable, and it's made primarily out of wood. Wood burns, no surprise. The frame is going to have the highest risk rating and the highest insurance premiums that go with that. Maybe you've got masonry with joists. Well, the joists tend to be wooden. And so that's going to be less flammable than entirely wooden, but more flammable than if you've got non-combustible construction. So there's a type of construction there that is mostly non-combustible, and that'd be ISO code 3. When it's full masonry, full block construction, maybe it's full concrete construction, that's masonry non-combustible. And then we have one step above that that's fire resistive. It's just important to realize that these types of buildings in class 4, class 5, they'll resist heat for longer, but there is no such thing as fireproof. You can never be completely free from the risk of fire. I mean, a steel building, yeah, the likelihood that that's going to burn is extremely low. And it'll be the parts that are made out of something else that'll go first. It'll resist heat longer, but again, everything can burn if the temperature gets hot enough. So there is no code that's completely risk-free, and that's worth remembering. So yeah, you can see this is an engineering approach, right? I mean, if I have a building, I'm stuck with what it's made out of. I'm not going to knock it down and build a new one for the purpose of reducing my fire risk. I might knock it down and build a new one for some other purpose, but probably not for the sole purpose of reducing the risk of fire. The idea is, hey, if I'm constructing a new building, let me think about this stuff. And yeah, as you would expect, the higher up you go, it might increase expenses. It might not. If you're just talking about a pole barn, you probably could go with steel construction, which would actually put you towards the top of the fire resistive materials. But pole barns by themselves aren't functional buildings for most uses. For some uses, it's fine. But you can't expect that to work for every single thing. You would never put a restaurant in that type of construction, for example. So there's trade-offs here, just like there are with everything else, but this is an engineering approach. This is when we're talking about construction, it's from the beginning that we have to be thinking about how are we building our building, and is reducing fire risk a priority? It should be if you have the chance to think about it from day one. Unfortunately, when people are building buildings, the people who want to build, usually they're not the ones who are thinking about reducing fire risk. It's the people who are doing the building who are thinking about that, if anybody is. So before you actually have a loss, what can you do? Well, you want to look at your heat sources, right? Where do those come from? So we have electrical heat sources primarily. We've got mechanical heat sources, and then, chemical and nuclear, maybe, depending on what we're doing. Wherever those heat sources are, we want to separate them from fuels, things that can burn. And then from there, it's thinking about fire going up, fire going sideways. How do you limit that? Sometimes that's a construction issue. We will put in there, a firewall is a literal term. We will build some walls out of completely fire resistive materials, again, trying to cut down the spread of fire either vertically or horizontally. And then full separation, that's an option too, to completely separate the fuel from the heat. In some cases, you might be able to do that. Wherever we can substitute non-combustible materials. This will come up later, but hotels do this with their bedding. So when you think about how do you reduce the fire load of a building for a hotel, they're thinking about, well, the bedding is a place where we can reduce flammability. Hospitals, same idea. And then the next step is, all right, how do we prevent arson? How do we prevent somebody from actually trying to create a fire on our property? And I wouldn't do that. You wouldn't do that. 99% of the population doesn't have that as a motivation, so you don't have to think about them. Unfortunately, it only takes one, right? One person to get the idea that starting a fire is worth doing, and now you got a huge problem. So how do we prevent that? We'll talk about some strategies that come up in just a second. Okay, so get back to where we need to be here. So in terms of controlling heat sources, what can we do? Well, we want to minimize our energy use. The less energy you use, the less heat that it's going to ultimately produce. You don't want any energy overcapacity. Energy that you're using that's more than what's necessary. That's not good. Minimizing flame use, right? You would definitely not want a situation where people are using candles ever. If it's if they're trying to control what an area smells like, we have all kinds of options other than scented candles. Candles are a huge fire risk. We don't ever want people using those in any capacity. We have all kinds of alternatives. That's a real easy place to minimize flame use. But wherever flame exists, is there a way to do this without? Because that's going to minimize your likelihood of flame spreading to a place where you weren't intended. We want our fires, we joked about this in the insurance contract, right? Or the fire has to be hostile before it's covered. It doesn't cover damage from friendly fire. We want all our fire to be friendly. Exactly as we intended. It's when it becomes hostile or unfriendly that it's a problem. And any place where you've got a flame, it's worth asking the question, is that necessary? Is there anything we can do? Some of the older equipment, when you think about something like a water heater, older water heaters have standing pilot lights. Those have flames that are always in existence. Newer water heaters use electronic ignition, and they don't have a standing flame in their unit. It's a small thing, but it does reduce the possibility of fire. If you've got excess heat being produced, what does your cooling process look like? So manufacturing here is primarily what we're looking at. Not unusual at all to have a lot of heat being used. And the question is, how are we cooling that down? How quickly are we cooling that down? If something gets heated up very, very hot, we probably just don't want to let it cool by the air. It'd be better if we had a cooling process to think about that. Electric surges and lightning is one. What can we do to protect against when a lightning strike comes? How can we arrange things so that the electrical system doesn't get overheated and start a fire? Outside of lightning, circuit breakers to make sure when we've got too much draw on a circuit that it shuts down. And then again, having the policies and procedures in place to let people know, look, when a circuit breaker gets tripped, that's telling you you've got a potential problem here. Don't shortcut the solution. Try to figure out what's going on and use a different circuit. Spread out that electrical load. Don't try to put it all on a single circuit because it's going to keep tripping, and then somebody gets the bright idea to force the circuit breaker not to break. And now you've completely undermined the whole purpose of a circuit breaker. And you've increased your source of heat and your risk of fire along with it. Whoops. There. Keeping your heat sources separate from fuel. This is really, really obvious. You want to keep your flammables away from heat. Mentioned it before, but this is where it comes up a lot. A furnace room, right, usually has a lot of unused space in the furnace room, and people will start to use that for storage because it's unused space. And they say, hey, we can just stack everything in here. You can, and then you're increasing the fuel load and dramatically increasing the risk of fire. The whole point of having space in your furnace room is to reduce the possibility of fire. Any chimneys that you have, there's going to be flammable buildup over time. Creosote is a problem. And it builds up, and if it isn't routinely cleaned, you can actually ignite a fire within a chimney. And that's a huge problem because, number one, you can't see it. Number two, you can't get at it easily. And so you're usually looking at major fire damage if that actually happens. In a restaurant, up the hood, you're going to have grease accumulating, and grease is flammable. So you've got heat going up the hood and grease accumulating in the hood. If you don't regularly clean that, it's a fire waiting to happen. So that's another example of removing that fuel. We want to separate the heat source from the fuel. And then, electrical wires, to the extent that you can insulate them properly, you want to do that. You always want people who are qualified, who know what they're doing, working on your things. It's always a temptation when you're a handy person to say, oh, let me see if I can figure out a way to make this work. You might be able to do it, but there's a good chance that you're not entirely up to speed on why they do things the way they do things. Most of the time it's to try to prevent fire. And so I have a lot of respect for people who can muddle through and figure out a way to come up with a working solution for something that's not working. I understand that. That's something you should be proud of if you can do that. There's certain areas where that's extremely dangerous. Electricity is one of them. And it's not just about fires. I mean, electricity, I think the angriest I ever got at my spouse was when I came home and she had been wiring something from a YouTube video that told her how to wire something up in a light fixture, and she hadn't turned off the circuit breaker. And I asked her, I said, do you realize that if you'd have done one thing wrong that you could have been killed? Oh, well, no, I saw it on the YouTube video. Oh, okay, well, if it's on the YouTube video, then you're safe. Then everything's fine. So that was something that always makes me think about this stuff. Professionals, there's a reason they're professionals, and they're usually worth what they charge. Free opinion, no extra charge for that one. But when you're messing with electricity, unless you know what you're doing, that's a real dangerous place to be. Not only for fire risk, but for risk of life and limb. So my strong advice is please don't mess around with electricity. Call somebody. It's worth the money that they're going to charge you to do it. when we talk about limiting spread, we need to talk both about up and down vertical fire spread, and then we also need to talk about horizontal fire spread. And that's what we're going to do in the next series of lectures. So we're going to cut it off here for now. Thanks a lot. You have questions about this stuff, send me an email. I'll do my best to respond, and we'll go from there. Thanks a lot, you guys.